My dear students, today we will study about the work done rotating an electric dipole in external electric field. In this case, we have calculated the amount of work done rotating an electric dipole in external electric field. Let a dipole of moment of electric dipole is vector P held in an external electric field vector E. All arrow lines show the uniform external electric field of direction is parallel to the plane of paper. We know when an electric dipole placed in an external electric field exert a torque on it. The torque exert on the electric dipole tau is equal to P sine theta. We had the torque exert on the electric dipole in lesson first. We had studied about the torque exert on the electric dipole in lesson first. Tau is equal to P sine theta. The amount of work done rotating the dipole at a small angle d theta. dw is equal to tau into d theta. Put the value of tau. Then dw is equal to P sine theta into d theta. Take an equation second. We have calculated the total amount of work done. The total amount of work done rotating the dipole in field from theta 1 to theta 2. Next, we first calculate the amount of work done rotating the dipole at a certain or small angle d theta. We get dw is equal to tau into d theta. We calculate the total amount of work done rotating the dipole in field from theta 1 to theta 2. We suppose that theta 1 is the initial angle on which the dipole placed in the electric field and theta 2 is the final angular displacement. Then integrate the equation 2 between proper limits from theta 1 to theta 2. Key integration dw is equal to integration theta 2 to theta 1 P sine theta into d theta. At w is equal to P sine theta into d theta. इंटीग्रेशन जो माइनस cos थीटा from theta 2 to theta 1, or W is equal to minus P cos theta 2 minus cos theta 1, or W is equal to P cos theta 1 minus cos theta 2. This is formula of amount of work done rotating an electric dipole in an external electric field. W is equal to P cos theta 1 minus cos theta 2. If theta 1 is equal to 0 and theta 2 is equal to theta, we can suppose that the electric dipole placed in an external electric field in parallel to the direction of field, and we rotate it at angle theta. Then initial angle theta 1 is equal to 0 and theta 2 is equal to theta. Then W is equal to P into cos theta 1 minus cos theta 2, or cos 0 is equal to 1, or W is equal to P 1 minus cos theta. If theta is equal to 0, then W is equal to P. If theta is equal to 180, then W is equal to PE, where cos 180 is equal to minus 1. Next, electric force between two dipoles. We have studied in lesson 1 electric force between two charges by Coulomb's law. F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Here we calculate the electric force between two electric dipoles. Consider two electric dipole AB and A dash B dash. Of moment of electric dipole is vector P1 and vector P2. Placed in axial position of distance smaller. Then the electric force between them F is equal to minus dW upon dr. We know work is equal to force into displacement. F into R upon R is equal to F, or W by R. WF into R की इक्वल होगा. So we differentiate the amount of work done with respect of distance. We get the electric force between two dipoles. Let vector E1 and vector E2 is electric field set up by electric dipole of moment of dipole is vector P1 and vector P2, where vector E1, the electric field set up by the first electric dipole of moment of dipole is vector P1, and vector E2 is electric field set up by the second electric dipole of moment of dipole is vector P2। और सेकेंड जो है E2 और फर्स्ट जो है E1 जो है सेटअप कर रहा है। तो फर्स्ट इलेक्ट्रिक डाइपोल जो होगा सेपरेट इन द इलेक्ट्रिक फील्ड प्रोड्यूस्ड बाय द सेकेंड डाइपोल, एंड द सेकेंड प्लेस इन द इलेक्ट्रिक फील्ड सेटअप बाय द फर्स्ट इलेक्ट्रिक डाइपोल। देन W is equal to W1 is equal to the work done by first dipole minus P1 into E2, the work done by second dipole is equal to minus P2 into E1. We know the electric field set up by dipole in axial position E2 or E1 is equal to 1 upon 4 pi epsilon naught 2 P1 upon RQ, just like E2 is equal to 1 upon 4 pi epsilon naught 2 P2 upon RQ. Taken the equation 1 and 2 and put the value of E1 and E2 in equation first and equation second, we get W1 is equal to minus 1 upon 4 pi epsilon naught 2 P1 into P2 upon RQ, and W1 is equal to W2. The work done by first dipole and second dipole have the equal magnitude. Now differentiate the work done, then we get F is equal to minus D upon dr minus 1 upon 4 pi epsilon naught into 2 P1 P2 upon RQ, or F is equal to 1 upon 4 pi epsilon naught 6 P1 P2 upon R power 4. It is formula of electric force between two electric dipole.